All right, everyone. Thanks so much for joining us for the NGA Energy Resilience for Water and Wastewater Systems webinar. My name is Tom Simchak. I'm a senior analyst here in the National Governors Association's Environment, Energy, and Transportation Division. Just some quick notes on logistics before we roll right into things. We will be unmuting everyone at a few points in the webinar for questions and answers. So please don't put us on hold as we would get your hold music, and you can manually mute yourselves in case of background noise and such. We'll also have a chat box where you can ask questions at any point during the webinar. We are recording the webinar, and registrants will get a link to that recording before too long once it's done and we've got all that ready to go. And we'd like to thank the Department of Energy for their support for this this work series, including the webinars we've been doing as part of it on energy resiliency issues. This is a topic that we've worked a lot supporting states on. We get a lot of questions on how states can plan across interdependent sectors, your water perhaps being the most important of those, and how resilience for energy impacts water planning in disaster and energy assurance situations. So we're really excited to bring these two speakers here to discuss this topic and hopefully get a good conversation going to help inform your own efforts within your own states. We have with us today Will Lauwers and Paul Stockton. Will Lauwers is the Director of Emerging Technologies at the Massachusetts Department for Energy Resources, or DOER. The Emerging Technologies Division is responsible for the state's energy storage initiative, Community Clean Energy Resilience Initiative, and alternative transportation technologies initiatives. Will has experience in the federal, military, and commercial world, working on RD&D for advanced power technologies, and he co-founded the Energy Experience Center at the University of Dayton Research Institute. After Will, we'll hear from Dr. Paul Stockton, who is Managing Director of Sonecon, LLC, where he, in that position and in past positions, he's been a leader in infrastructure resilience, continuity planning, and installation and personnel security, involved quite broadly in U.S. national security and foreign policy. Previously, he was the Assistant Secretary of Defense for Homeland Defense and America's Security Affairs from 2009 to 2013, and served as the DoD's Domestic Crisis Manager, including responses to Superstorm Sandy, Deepwater Horizon, and other disasters. So with that, we will hand over to Will to discuss a little bit about the work that he has been involved in and Massachusetts programs providing energy resilience for water and wastewater systems. Will, take it away. You should have control slides.
Great, thank you for that introduction. Again, I'm Will Lauwers, Director of Emerging Technology for the Massachusetts Department of Energy Resources, and it's a pleasure to join you here to discuss the Baker-Polito administration's energy policies in Massachusetts. Here at the DOER, our objective is to provide a clean, affordable, and resilient energy future for the Commonwealth. So let me see if I can get these to scroll forward. Here we go. So to kick it off, I just wanted to provide a brief overview of, in September of 2016, Governor Baker signed Executive Order 569, which establishes an integrated climate change strategy for the Commonwealth. And there are two key objectives of this executive order, including mitigating and reducing greenhouse gas emissions in the state and building resilience and adapting to the impacts of climate change. So there are a number of tasks within this executive order which incorporate planning for and adapting to natural disasters and ensuring that we have resilient infrastructure in place to ensure continuity of services through disasters. And to the bottom right is an image of one wastewater treatment facility in Massachusetts, which we have awarded through our Community Clean Energy Resiliency Initiative, where they are installing an anaerobic digester to provide power and heat energy to their facility and enabling it to Black Star Island. So we are also performing grant programs to support this. So just to give a quick background, not being certain of the backgrounds of folks on the phone, providing a quick definition for resilience, Presidential Policy Directive 21 provided a definition of resilience. And essentially, it's important to understand that resilience is a time-varying description of the level of service that's being provided. And it's not necessarily an assurance of 100% of service being provided 100% of the time. Instead, it has more to do with how long the impacts are felt and what the depth of those impacts are, depending on what the disruption event is. So moving into specifically water infrastructure at stake, there are typically two primary types of water infrastructure in place. There are centralized infrastructure systems where there are centralized treatment plants, centralized potable water treatment, and then distribution of the water. And then there are more distributed infrastructure type areas where facilities have their own wells on site and facilities have their own waste treatment on site, often in the form of septic treatment. And so these two different types of water infrastructure can have very different considerations and potential solutions to back up their energy systems and make their energy sources more reliable and more resilient. On the centralized infrastructure side, the treatment process is very energy intensive, and much of the process and energy consumption is associated with large pumps. And so when considering how to make a facility resilient, it's important to consider the characteristics of those pumps when designing a system. So there's a lot of specific engineering required specific to the site, in large part associated with the inrush currents that those large pumps draw. That in contrast to a residential type water system where typically there's more space available. Permitting on backup generation can be a bit more simple depending on what tier area you're in for emissions. And typically there's also more space available to provide some forms of backup generation, such as solar PV plus storage. So in general, there are a few standard ways that folks can improve their resilience. And these aren't necessarily specific to water infrastructure, but they can inform how to go about strategizing to improve the resilience of water infrastructure. So the typical ways to improve a facility or a service's resilience include having a plan in place before the disruption event so that everyone understands their roles and responsibilities, and so that it's understood what the process will be immediately post-disruption. Reducing the reliance on the service. So by reducing one's reliance on the service provided, you're reducing the impact of a disruption. In this case, with water infrastructure, it's very difficult to do. Humans will continue to have a requirement for potable water and for wastewater disposal. So that's a difficult avenue to try to take to improve the resilience. There are options to disaggregate and prioritize the recipients of the service. So this is, in effect, identifying critical areas that should be provided the service if there's limited ability to process water at a given time. So that ability to prioritize and then the ability to disaggregate who has access to service can enable partial operation post-disruption event. And then finally, implementing redundancies to mitigate single points of failure. That's both on supply requirements, such as energy supply, and then it's also based on mitigating single points of failure for supplying the service to the end user. So having multiple avenues, multiple pipe systems to deliver the service so that those aren't single points of failure either. So moving on to resilient energy technologies. Here in Massachusetts, our focus has incorporated diesel generator backup, which is typically in place to meet regulations for many industries that have been identified as critical. We've focused on combined heat and power systems and fuel cell systems, combined heat and power being applicable for facilities that have a large thermal load, fuel cells for facilities that don't have that thermal load, and then solar plus storage. And each of those solutions have their own benefits, but they also have their own cons. So they each do rely on another form of energy to be available for them to continue to provide energy services. So in the case of diesel, you need access to the diesel fuel, and oftentimes for resupply, that means you need access to transportation systems. Similarly for CHP, you need access to natural gas lines. And then for solar plus storage, the sun needs to be out. You need to have that energy generation. So as of right now, there is not really a silver bullet for resilient energy supply. However, individually, each of these technologies can make a facility more resilient. And in combination, there are opportunities to maximize the cost effectiveness of a system and improve the resilience. So one of the key considerations that we've been focusing on here is identifying ways to improve resilience with cost-effective technologies. So many of the ways to improve the resilience of facilities like this are very capital intensive, and it can be a lot easier to receive approval to spend to go forward with large capital projects if there's an ROI associated with the project. So one of the key things to consider early on is energy efficiency. Energy efficiency is typically cost-effective before considering resilience, but it's particularly cost-effective after considering resilience, because every kilowatt of demand that's not required to be backed up is a kilowatt that's saved in day-to-day operations, but then it's also saved in sizing of the system to provide the backup. And then beyond that, for generation systems, looking at CHP plus storage, or solar plus storage, you have the energy cost offsets in your day-to-day blue sky operation, and you also can have demand charge management offsets in your day-to-day operation. So the benefits of those can help provide a positive ROI on the system, while at the same time improving the resilience of the facility. An additional benefit of having facilities that operate in a day-to-day operation as opposed to a diesel generator is the condition of the equipment is known. So it's maintained and it's operating day-to-day. And if there's an issue with it, it can be remedied rapidly and remedied during a normal operation day, as opposed to identified and remedied post-disruption, which can be much more difficult. So moving specifically into energy storage and its applicability here, we recently completed the energy storage study here in Massachusetts, and it came to some surprising conclusions about how much energy storage we could readily benefit from in Massachusetts. And one of the reasons behind that was in electricity, we have a very low amount of energy storage today. And in most supply chains, commodity supply chains, energy storage is a key technology which enables more resilient operation and more efficient operation of the supply chain. And it makes it more resilient to disruptions at the various critical delivery points through the supply. So this was one of the key findings for electricity energy storage. In addition, we found that a majority or a significant portion of our costs associated with electricity in the state are associated with peak demands. And that's because the entire system is designed to generate, transmit, and distribute the peak demand of electricity. It's sized for that, but it's used, the capacity factor of it is relatively low. So those costs associated with those peak demands are very high. So energy storage can also provide day-to-day cost benefit savings by reducing those peak demands, in addition to providing resilience benefits. So a large part of our focus has been incorporating energy storage into system designs to provide resilience. And it's been, we found it to be affordable. The prices have been declining. It's been enabling cost savings for the facility that hosts the storage. It's enabled more efficient operation of the generation on site, whether it's a CHP system that's better able to operate in its efficient operating profile, or to better size a CHP system to meet the thermal load, and to enable black starting and islanding of CHP facilities, fuel cells, and solar. So typically installing distributed generation does not inherently mean that you have the ability to supply energy through an outage. And energy storage is often a way to enable that islanding and black start and provision of power when the supply of electricity is disrupted. And so the policies that we have in place currently that have helped to support the rollout of resilient energy systems have included collaborating with our municipalities, which are typically the owners and operators of water treatment facilities. And we have a few avenues to collaborate. We have our Green Communities Initiative, which offers technical assistance and grant funding. And then we also have the recently established Municipal Vulnerability Preparedness Program, which helps municipalities provide assessments of their risks and exposures and helps them to prioritize their capital investments to improve their municipal resilience, whether that's water or otherwise. We also have a focus to collaborate across state agencies. We work very closely with our Emergency Management Agency, as well as our emergency and police agencies. Our Leading by Example program has enabled us to demonstrate by doing. So it's a program where we demonstrate these technologies, resilience assessments of facilities, and distributed generation technologies at state-owned and operated facilities. So we work very closely with our Department of Capital Asset Management as a part of that. For energy efficiency, we have a major commitment to energy efficiency here in Massachusetts. We've been ranked #1 in the nation for the past 7 years, and ensuring that facilities like water treatment facilities are maximizing the way that they leverage the energy efficiency programs available to them is a key way to reduce their energy demand before they start trying to size energy systems to supply their need. On the distributed generation side for powering the facilities, we have a new solar program that will be rolling out this summer, which incorporates an incentive for pairing energy storage with new solar, and that will help make it easier for customers to decide to install a resilient energy system instead of a passive solar system that does not operate during an outage. Additionally, that solar program provides an additional incentive when the off-taker of the energy is a public entity, which is often the case for these water facilities, so it helps for them. We also have an alternative portfolio standard, which incentivizes CHP and fuel cells. And that's been a critical way of incentivizing combined heat and power systems, which we do consider to be a clean technology here in Massachusetts. And beyond that, we have demonstration grants in place. We've issued $20 million in the Energy Storage Initiative and $40 million in the Community Clean Energy Resilience Initiative, both of which have supported various distributed technologies, feasibility studies for facilities, and energy storage being paired with facilities to back them up. In addition, we're now working on providing tools to inform decision makers. So we found that there's a lot to energy resilience, and it's a very complex subject, and we can't expect every decision maker to become an expert in resilience. So we are doing what we can to provide a clearinghouse for all the relevant information to the decision makers, but then also we have a grant where we are currently evaluating the proposals to try to digest that information and make it as simple and actionable as possible for users. So that is something that we have underway. And And with that, I think I'm at my 15 minutes, and I'd be glad to take questions.
Excellent. Thanks so much, Paul. Will, that was really great to hear. We will now unmute attendees, but please keep yourself manually muted, particularly if you've got some background noise, and see if there are any questions from the crowd. We unmute all.
Yeah, I don't know if there's a button that does it.
While we are unmuting you, you can also, please do keep yourself on mute because we do hear. You can also type your questions into the search box. Into the question box.
While we're doing that, well, you briefly touched on at one point on your slides departmental collaborations. Also, I think a lot of these issues touch across various levels of government, so state, local, county, that sort of thing. How has the program coordinated across those levels of government, and what has the state done to help support that? Have we got you there, Will?
The Energy and Environment Agency of Massachusetts to collaborate with the Massachusetts Emergency Management Agency in developing a state hazard mitigation plan. So there has been top-down direction to collaborate in the development of statewide planning efforts. And then in addition, existing programs as a result of the Green Communities Act in Massachusetts have provided additional ways in which the agencies collaborate.
Great, thanks so much.
So this is Andrea in Missouri. I have a question.
Go ahead.
Can you hear me?
We can.
Okay, so I just wanted to ask a little bit more information about that collaboration, and my question was along that lines as well. I was wondering if through any disaster in Massachusetts or any projects through any disaster recovery, if you all have had any specific disasters where you've worked with your state emergency management agency or FEMA on a particular wastewater treatment facility where you have gone in and, used some of these resilience, tactics and kind of deployed some of this where that's worked. And I guess I'm asking because we have several facilities in our state right now that I could see where this could be applicable. And there's a large wastewater treatment facility that has been damaged numerous times, and we're getting ready to go through, basically a complete destruction and rebuild of this facility. And I'm hoping that we can build, obviously we're building in some resilience and hoping that some of these, tactics and uses can be, can be used. And so I'm just wondering if you've had that experience.
Yeah, that's a great question. So post-disruptive event and actually leading up to them when they can be anticipated, we do work with our Massachusetts Emergency Management Agency. We will often have personnel stationed at their bunker headquarters. Additionally, there will be a representative from each of the utilities stationed at the bunker, so that there's in-person immediate chains of communication to assist with sort of the triage and prioritization of bringing facilities back online as part of an energy restoration effort, particularly an electricity restoration effort. So oftentimes that is sort of the method for status quo prioritization and recovery. With regard to then more long-term planning for capital investments to reduce the need to prioritize these facilities, assuming that they're then able to operate without a grid supply. We found that's typically more a component of the engineering design and part of the facility upgrade process, so capital budgeting. So it sounds like at the early stages where you may be for design of a new facility, that's the ideal time to be identifying how you can minimize the on-site loads and then design a system size to back it up. And I would say recently, facility issues we've had have included where we've backed up or where we had power at treatment facilities, but we didn't have backup power at pumping stations. And as a result, we had some effluent spillage into riverways, which is definitely not the preferred solution. So we are currently also going through an evaluation of where improvements can be made so that we can start designing energy systems for the future, so that doesn't happen in the future. But I think that is sort of, we've been treating them as two separate tasks. One is the immediate recovery post-disruption, and the other is design to mitigate the impact, which is a bit longer of a process, but hopefully a more impactful process.
Great. We have a question sent by text from Vermont. Two questions. One, what is the reasoning behind diesel generators as opposed to LP? And two, are you using any of FEMA's hazard mitigation funds?
Great. So diesel traditionally has been the very simple off-the-shelf solution. It takes very little thought to size and install. So without external input or feedback or policy support, we found it just tends to be the go-to solution. So that's what we tend to see installed in place if further consideration for the energy system isn't necessarily provided. On the FEMA funding side, our emergency management agency does utilize FEMA funds, and I think does have access to the various generator programs and asset programs. We at the DOER are not a part of those funding sources, but we do participate in some of the DOE funding sources, such as SEP.
Great, thanks. I think we should move on to Dr. Stockton now. Sorry for those who I'm leaving behind. We will have some time at the end of our second speaker to ask further questions. So please hold on to those questions and comments. So Dr. Paul Stockton, over to you.
And Will, that was a terrific presentation. As we heard in the introduction, I provided defense support to FEMA and through FEMA to the states affected by Superstorm Sandy, Hurricane Irene, and other events. And I learned some harsh lessons about what it takes to be prepared against severe events and the importance of sustaining and rapidly restoring a water and wastewater service as absolutely central to public health and safety. But what I'd like to talk about now is not preparedness so much for Sandy scale events, but the risk of what I call black sky events. That is, power outages over major portions of the United States, multiple states, that last 4 weeks or more. And there are natural hazards, of course, that can cause such long duration power outages. Those of you in states along the Mississippi River are familiar with the risks of the New Madrid seismic zone having a recurrence of the 1812 level earthquake that would cause liquefaction of the ground underneath power transformers and high voltage transmission towers, everything required for the grid to function. And also require, of course, then restoration of these long lead items of equipment that could take not just many weeks, but potentially months to fully restore service. Same is true of the Cascadia Fault Zone, the Hayward Fault in California. But my particular area of interest is the risk that adversaries will launch cyber and physical attacks on the energy sector, of the sort that were posited in the recent GridX exercise. And I say attacks against the energy sector as a whole on purpose, because I think we need to assume that if Russia, China, or some other potential adversary is going to take the risks of attacking the electric power grid, we should assume that they'll also attack the flow of natural gas on which power generation depends, not only in Massachusetts, but in many of the states for the folks on the line today. So when we think about what it's going to take to sustain emergency power and have, for example, microgrids that function, if those microgrids depend on natural gas in order to generate power, if emergency power generators at water utilities depend on the flow of diesel or other liquid fuels, distillates, in order to sustain emergency generator operations, folks, that will all be at risk in combined cyber and physical attacks. So that's a little context for my perspective on the issues of power resilience in the water sector. I'd like to talk about some obvious and very valuable mitigation opportunities to deal with the risk of black sky events, and then talk about some more extraordinary measures that you might have in your back pockets, or maybe the better phrase is arrows in your quiver, to deal with the very worst kinds of events. Let me preface my remarks, though, and my recommendations by saying, first of all, congratulations to all of you who are doing what you can to strengthen the resilience of water and wastewater systems against normal outages, because we can envision all of the work that's being done today, the terrific progress underway, as getting us better prepared for black sky events from a bottom-up approach. That is, measures taken under EPFAT and other initiatives in order to build power resilience today for normal disasters. That's the foundation on which to take additional measures for black sky resilience. At the same time, I think we need to discuss opportunities for top-down planning, and that is the kinds of extraordinary measures that you'd never use unless public health and safety were facing catastrophic risks, and you do things that ordinarily would be off the table. Let me talk about two things that I think can be done in terms of advanced planning. First, I want to talk about emergency power and build on some of the terrific ideas that Will shared. And then I want to talk about emergency management and incident management from the perspective of water and wastewater systems. The first topic, that is strengthening the ability to operate. One of the lessons learned, harsh lessons learned for me during Sandy especially, but also other events, is that generators burn out. Once they've been operating for a number of days, they need to be maintained. They need to be serviced, or else they begin to break down. And the challenge of finding and delivering and installing replacement generators is significant in Sandy scale events. But in a black sky event, you're going to find two additional challenges. First, there's going to be an overwhelming demand for replacement generators. The number of hospitals and other facilities, gas stations, that are going to be clamoring for replacement generators after they've been operating on their existing ones for many days. That demand is going to be overwhelming compared to the limited supply, the limited stocks maintained by FEMA, by USACE, U.S. Army Corps of Engineers, and contractor providers. There's going to be a mismatch between supply and demand, and even though I think we're making great progress in having emergency managers understand that water systems and wastewater systems should be first in line for fuel and replacement generators, there's going to be a problem of supply and demand that's going to be extremely difficult to resolve. Secondly, fuel resupply. Of course, water systems and wastewater systems are doing a lot better than they used to in terms of having distillates that they need stored on site, although environmental regulations often constrain that on-site storage. But what we saw in Sandy, in New Jersey and elsewhere, is that the resupply of fuel becomes problematic because, again, there are so many customers. But there's an additional problem that we'll face in black sky events, and that is the supply chain and transportation systems necessary to get fuel from where it's being refined to your water and wastewater system. That is going to be an immense challenge because there's a blackout. And because many of these transportation systems, ranging from gas pumps to everything that trucks require in order to get marshaled and dispatched to where they need to go, an extended blackout is going to seriously degrade all of those systems on which fuel resupply depends. So you'll have both the mismatch between supply and demand, equivalent to that which applies to replacement generators, but you'll also have the entire distillate fuel chain at risk of serious disruption because of the effects of the blackout, because of the lack of electricity for all of the electricity-dependent components on which that fuel chain relies. So we're going to have big problems in terms of generators and fuel resupply. Begin to account for those. Begin to have discussions, for example, with providers of fuel so that you can reach a mutual understanding of the degree to which your contractors are really going to be able to prioritize resupply to water and wastewater systems in a way that reflects the absolute critical importance of those systems to public health and safety. Although I'm focusing on emergency power, let me, of course, raise one other obvious sustainment requirement, and that is chemical resupply. Again, water and wastewater utilities are doing an increasingly good job of storing treatment chemicals on site to the extent that environmental regulations permit. But in a black sky event where transportations are seriously disrupted by the loss of electric power on which they depend, your ability to be resupplied with the chemicals essential for water treatment and in some cases for wastewater treatment is going to be in jeopardy. So again, start thinking not only about preparedness against Sandy scale events, but longer duration outages that affect the resupply of chemicals and other, let's call them consumables, on which your systems depend. So I've said a little bit about what it takes to strengthen the ability of water and wastewater utilities to sustain operations with emergency power. Let me then move on to an additional question, my second major topic, which is incident management. Because you're probably already thinking, geez, how are we going to maintain normal levels of service in a black sky event? And the answer is, you probably can't. It probably can't be done, at least not for multi-week outages of the sort that could be caused by earthquakes or combined cyber kinetic attacks. And so, as Will pointed out in his introduction, resilience doesn't necessarily mean that you can do everything all the time that you could in a blue sky environment. And what I'd like to urge you to do is to begin to think about what kinds of extraordinary measures you might want to have in your back pockets in order to sustain the most critical functions in your for your customers. Let me give you an obvious example, right? If there's a lot of variation in elevation in your service territory, you may not be able to sustain service to the highest elevation portions of your service territory. It takes a lot of power to pump the water up there, and if you're looking at a long duration power outage, you might want to have some contingency plans in your back pocket to be prepared to not serve all areas. You may also want to have some plans to make sure that if you can have the necessary valving, meet the other infrastructure requirements, that you can sustain water service no matter what to major hospitals and other customers that are critical for preserving public health and safety. I would say you should also consider backing away from maintaining your usual levels of pressure, even if that puts potable water at risk. My view is that, and again, this is a little extreme, that although you always want to have meet your standards for drinking water, that raw water sometimes may be a difficult to meet but important goal to achieve. That is, sustaining sufficient pressure in your pipes with water that may not be drinkable so you avoid pipeline collapse. Making sure, for example, that you have sufficient water in the system, even if it's not drinkable, for to provide for fire suppression and HVAC service, and the flow of water necessary for wastewater systems. So those are some criteria for incident management that I'd urge you to take into account. And there's plenty more, but I'm running up on my time limitation here. I want to emphasize the value of what everybody on this call is doing to prepare for, let's call them normal disasters. That kind of bottom-up approach is enormously helpful. But I'd also urge you to consider the top-down work that I've been describing, to have in extremis options already available to political leadership to consider. Obviously, these extreme measures would only be taken in the most extraordinary of circumstances, but those circumstances someday could affect the United States, and building preparedness for them is prudent. Thanks very much, and I welcome your questions and comments.
Thanks so much. That was really a great perspective to hear for the crowd. Let's see, we'll start unmuting folks, but also as it's a little bit of a slow unmuting here, feel free to use the text questions box, and I can read those out for the group. We had a question from Len Hui earlier about using methane at a plant for CHP. Perhaps for Will?
Sure, so that's part of the design of the North Andover facility. Part of our Greater Lawrence Sanitary District effort is an anaerobic digester, which does use the methane, the heat of which is used for the dryers, and the electricity is used for on-site consumption. So definitely something feasible, something that we're looking at, and something that we have an ongoing grant to support.
Great, thanks. We're getting a bunch of feedback noise when we try to go through and unmute people. So if folks could go ahead and type any questions they might have into the question box, that'd be great. In the meantime, for either of you perhaps, have you looked at or thought much about staff resilience? I mean, certainly keeping a important facility up and going requires, you know, the engineers to be there on site, keeping it all going. But if key people are panicked at home, nailing a tarp to the roof and not showing up to work, that obviously is a lot harder. Is that something that's been looked at, and is there any planning or programs around that that you either of you are aware of?
This is Paul. I'll take an initial whack at that. Absolutely. The need for staff and personnel resilience is just as significant as it is for equipment resilience and sustaining the flow of fuel and replacement generators that water utilities are going to require. We saw some of this in the financial services sector, where some banks in Lower Manhattan had done a terrific job of making sure that they weren't inundated by storm surges and that their emergency power was up and running. But their workers lived in New Jersey or elsewhere, couldn't get in to conduct staffs, and in some cases, of course, were worried about taking care of their own families in the midst of the storm. All of these considerations, how are you going to get your workers to where they need to be in a severely disrupted, and how are you going to give them the confidence that their families are being taken care of so that they can come to work for however long is needed? Those initiatives are important, and right now, the Red Cross and other VOLADs are building plans to work with lifeline infrastructure owners and operators to provide targeted assistance to the families of key utility workers so that they can have the confidence that they need to leave their families in good hands and come and provide the functions on site that are required.
Great, thanks so much.
Hi, this is Bevan Bukeister at NGA, and I have a question for both of you. Could you, to sort of bring this down to on the ground level, could you both give us examples of things that have gone wrong and gone right in actual disasters that you've been involved in or analyzed, and the lessons learned from them with either fuel supply or backup fuel or anything like that?
If you'd like, I'd be happy to start. Just echoing Paul's comment about generators burning out, I think that's been a lesson that just about every community that's experienced an enduring outage has experienced. The failure rate of diesel generators is very concerning, and it's something that's typically not accounted for in the planning process. So many facilities believe that they do have an extended duration resilience just because they have on-site fuel supply for maybe an extended runtime. But those failures can be really problematic, and facilities then that thought they were resilient are suddenly dialing in and calling for emergency support at the same time that all of the emergency responders are already fully busy. One of the key things that we've learned from that has been doing everything we can to enable community members to shelter in place so that our emergency personnel are able to respond to the true emergencies instead of providing taxi services and people transportation services. And so that's one of the reasons that we've also had this focus on water infrastructure is we see it as one of the key enabling requirements for folks to stay in place.
I completely agree. And let me add a punctuation, exclamation point rather, on sheltering in place. The great evil for all of us collectively to avoid is unplanned mass migrations. We saw that some years ago in hurricanes in Texas. If you have hundreds of thousands of citizens fleeing a hurricane or other event in their POVs because there is no water service, and they are fleeing on their own to some place that they believe still has water, sometimes maybe a state or two away, that will create a human catastrophe of unprecedented scale for the United States. Sheltering in place, whatever it takes to enable people to shelter in place, that is the most important goal for black sky preparedness. And again, goes back to my major points of what does it take to sustain emergency power in a harshly disrupted environment. And then secondly, what kind of arrows in the quiver do you want to have to enable people to shelter in place, even in the most difficult of circumstances? You know, boiling water, other kinds of water treatment, if all you can provide is raw water, fine. Let's get ready in order to achieve that level of minimalist service.
Thank you for that. So this is Dan Loft with NGA. As a time check, we have a couple of minutes left. So if anybody does have final questions, please add those to the box. One that I wanted to ask, which is, I know, always an important factor and often a challenge for the states, has to do with funding and financing for resilience measures, particularly with critical infrastructure like energy and water facilities. So Will, maybe starting with you and then turning to Paul. Wondering, Will, first, if you can describe where the funding sources have come from for the work that you've done in Massachusetts, particularly your grant and loan programs and some of the R&D that you've supported. And then Paul, welcome your thoughts on what other states you've worked with have done and where states might go to consider funding to support this work.
Sure. So to kick off for us, most of the incentive programs that we have are through our portfolio programs. So we have our renewable energy portfolio and our alternative energy portfolio. And those are designed to incentivize the deployment of distributed generation. And a part of that is those provide direct incentive to install distributed generation. And the obligation falls on the electric distribution companies and competitive suppliers in the state to meet minimum percentages of supply from clean energy. And if they do not meet those minimum obligations, then there is a alternative compliance payment opportunity for them. So many of our grant programs have been funded through the alternative compliance payment funds that we've received. And the purpose of those funds is to deploy those clean energy technologies that were supposed to be deployed through the incentive structure. So it's in either way, the residents get the clean energy technology. If it's through the form of ACP, then we have more discretion and direction over where those funds go, so we can make sure that they are including initiatives like improving the resilience.
I would, I'm sure some of you are listening to my remarks on what it takes to be prepared for black sky events, and you're thinking, geez, what is he smoking? We barely have enough investment funds available to keep up with what we need to sustain our operations and do minimalist modernization. I'm aware that the water sector has very few resources relative to need. And my answer is always work together with your public utility commissions, work together with your emergency management partners to raise awareness at the highest levels of the criticality of water service, but also the need for water system resilience as a component of national security. Absolutely, all of you contribute to national security by virtue of what you can do in order to ensure that even in the worst days created by adversaries, Americans will have the water and wastewater service they need to get through. That message needs to get out. I'm going to NARUC this summer in order to beat the drum. Please join me in doing so, because what you do is incredibly valuable to the nation.
Excellent. Thanks so much. That brings us pretty much to our hour. Thank you very much to our speakers. We've really valued the perspectives you guys have been able to offer here. Hope that states, if they have further questions, can reach out to us here at NGA. We can pass those along. And to all participants, thanks so much for joining us. We hope this has been useful for you and helped to provide some interesting food for thought as you consider your energy and water system resiliency programs, policies, etc. So I think that concludes the webinar. Glad you could join us this afternoon.